Nat 4-5 Physics, Freefall and Terminal Velocity. The key areas we will look at today are the definitions of freefall and terminal velocity, describing the journey of a skydiver using Newton's laws of motion, and some review questions on Newton's laws of motion. Freefall. Freefall is when an object is falling freely due to the force of gravity. Terminal velocity. When something is in freefall, it accelerates, so it gets faster. But it doesn't just get faster forever. There comes a point where it gets to a constant velocity. And this is when the driving force is balanced by the frictional force. And we know if we have balanced forces in opposite directions, we must have a constant velocity, which is what this velocity is. So terminal velocity is the highest speed something can reach while it's in freefall. The graph on the next slide shows how the velocity of a parachutist varies with time from the start of the jump until they reach the ground. Explain each section of the graph using Newton's laws of motion. Your explanation should include the terms balanced, unbalanced, free fall, and terminal velocity. I'm going to go through each of the sections of the graph with you and show you how each of them should be explained. Here is the graph itself. We have 5 different sections to explain. Section O to A. When the parachutist leaves the aircraft, they will be in free fall. The frictional force, called air resistance, will be less than weight. There will be an unbalanced force acting on the parachutist, and so, according to Newton's second law, the parachutist will accelerate. They'll get faster. Section A to B. At point A, the air resistance has increased to become equal to the weight of the parachutist. The forces are balanced, therefore the acceleration is now 0. And so according to Newton's first law, the parachutist is travelling with a constant velocity called terminal velocity. At point B, the parachute is opened. Section C to D. There is a rapid increase in air resistance when the parachute is opened. The upwards force is now greater than the weight for a short time. You can see that from B to C there is a rapid decrease in velocity. This is because of this rapid increase in air resistance and the upwards force being greater than weight. At point C, the air resistance and weight have become balanced again. The acceleration is now 0 and the constant velocity is much lower. At point D, the parachutist reaches the ground and you can see there is another reduction in velocity, but much smaller this time, so the parachutist doesn't get harmed when they reach the ground. Review questions. Question 1. An unbalanced force of 96 kilonewtons acts on a train, which accelerates at 1.2 meters per second squared. Calculate the mass of the train. We can see that we have a force, so 96 kilonewtons, and we have an acceleration, 1.2 meters per second squared. And the question wants us to calculate the mass. So the equation we're going to be using is force equals mass times acceleration. Our force is 96 kilonewtons. Our mass is what we want to calculate. Our acceleration is 1.2 meters per second squared. Before we use our equation, we need to notice that the force just there is in kilonewtons, whereas we need it to be in newtons. 96 kilonewtons is equal to 96,000 newtons. Now we can use our equation. F equals ma. So 96,000 is equal to m times 1.2. So rearranging this, we get our mass equaling 96,000 divided by 1.2. And so 96,000 divided by 1.2 is equal to 80,000. And because that's mass, it's measured in kilograms. Question 2. A satellite with a mass of 50 kilograms is being moved to a new location in space. The forces acting on the satellite are shown below. Calculate the acceleration on the satellite. Having a look at our numbers again, we have a mass, we want to calculate an acceleration, and we have some forces. So writing down our letters, force, mass, acceleration, it's the same equation as before, but we have 2 forces there. So before we can use this equation, we need to calculate the overall unbalanced force. And we can remember the unbalanced force equals the force forwards minus the force backwards. So in this case, 12 minus 2, Our unbalanced force is 10 newtons, and that will be acting to the right. Our mass was 50 kilograms, and our acceleration is what we want to work out. F equals ma, so 10 equals 50 multiplied by a equals 10 over 50, and so 10 divided by 50 is equal to 0.2. Because that's acceleration, it's measured in meters per second squared, and remember, because it's a vector, we need a direction. It's the same direction as the unbalanced force, so that will be moving to the right. Question 3. A skydiver with a mass of 75 kilograms is shown below. A. Copy the diagram and add the labels for the forces acting on the skydiver. B. Calculate the weight of the skydiver. C. The unbalanced force on the skydiver is 185 newtons. Calculate the acceleration of the skydiver. And finally, D. State the value of air resistance acting on the skydiver. We've got quite a few questions to go for here, so let's just go for our first one. Copy the diagram and add the labels for the forces acting on the skydiver. We have our picture of our skydiver just here, and we've got two arrows, so we're just going to be putting in two forces. The force downwards on the skydiver is their weight. So that's the only force we need to put in just here. And the force acting opposite to the weight is air resistance. So that's our first part done. Our second part to the question is calculate the weight of the skydiver. Thinking back to our equations, we know that weight equals mass times gravitational field strength. So we need W, M, and G here. We want to calculate our weight. Our mass is 75 kilograms, and our gravitational field strength, presuming our skydiver is on Earth, is going to be 9.8 newtons per kilogram. Using our equation, W equals mg, we say that W equals 75 multiplied by 9.8. And so I'm just popping that into my calculator just now. 75 multiplied by 9.8 is equal to 735. And that's in newtons because weight is a force. So we've done part B, now we're going on to part C. The unbalanced force on the skydiver is 185 newtons. Calculate the acceleration of the skydiver. So we've been given a force, which is 185 newtons. We want to calculate an acceleration, and we've also been given a mass. Remember, that was 75 kilograms. So this time we're using F equals ma. Popping our numbers in, 185 equals 75 times by a. Our acceleration is going to be equal to 185 divided by 75. And so this is equal to 2.46 recurring. So we can round this to 2.5 meters per second squared. Now I've just got one part of the question left. D. State the value of air resistance acting on the skydiver. Let's draw ourselves a little picture to help out with this. So again, we've got our skydiver. We've got their weight acting downwards, which we calculated to be 735 newtons. We don't know what the air resistance is. We can put a little question mark there. And we have our overall unbalanced force of 185 newtons. What we have to do now is think back to our equation. Our unbalanced force equals our force forwards minus our force backwards. Therefore, 185 equals 735 minus our force of friction. And so our force, or sorry, not friction, air resistance even, our force of air resistance is going to be equal to 735 take away 185. And so this is going to be equal to, I'm just popping it into my calculator again, 550 newtons. Question 4. Use Newton's first law to explain why a space vehicle does not need to have its engine switched on in outer space. Part B. Use Newton's second law to explain how a space probe is able to land on an object in space. And C, use Newton's third law to explain how a rocket is launched. Let's think about part A first. We want to use Newton's first law to explain why a space vehicle does not need to have its engine switched on in outer space. Well, in space there are no frictional forces. This means the space vehicle will continue with a constant speed. So you don't need to apply any more force to this for it to travel at this constant speed. For part B, we need to explain how a space probe is able to land on an object in space. And so we can use thrusters on the space probe, and they create an unbalanced force, which will allow the space probe to decelerate and or change direction, allowing it to land. And finally, we need to use Newton's third law to explain how a rocket is launched. When the action force is the rocket on the gases, the reaction force is the gases on the rocket.